Namaste. This is JV and Dr. Vishal Saxena, Professor in Mathematics in Faculty of Education and Methodology in the JAYOTI VIDYAPEETH, Women's University, Jaipur. So I'm going to take a lecture on the topic of probability distributions, and today we are going to discuss the binomial distribution, which one is the discrete probability distribution. And today's lecture just belongs to the course of research methodology in biostatistics, and it is in the BPT 6th semester and B Pharma 8th semester. So the today's topic is probability distribution. As already we know that what is probability. Probability means the chance of the chance of occurrence for any particular event. So probability distribution is a different one from the probability. Probability distribution means it is a kind of the distribution for the probabilities. So it can be defined as a probability distribution means it provides all the possible outcomes for any random occurrences. So for any random occurrence, if we have to just give the possibilities for the all possibilities of outcomes, and this means the probability of all the possible values of random variable, then it is called probability distribution. So this is additionally stated as a collection of potential outcomes from any random experiment depending on the underlying sample space. So just we can say means this is additionally we can say it is a collection of potential outcomes from any random experiment depending on the underlying sample space. Means what are the probabilities for the or what are the possible outcomes for the different random variable values underlying in a sample space. So for a sample space, the probabilities for the every possibility of random variable is called probability distribution. So the probability distribution of a random variable determines the likelihood that it will have an unknowable value. So this distribution can have continuous or the discontinuous mixed random variable. So ultimately, the probability distribution can be defined for the continuous random variables, for the discrete random variables, and for the mixed random variables. Given that the random variable has a property of probability mass function. So when we discuss about the case of the discrete probability distribution, then we will just say the probability, we will find that the probability mass function, and it is given by a formula. So later on with the discussion of the discrete probability distribution, we will find the probability mass function, and when we discuss the continuous for the probability distribution for the continuous random variable, then we will use the concept of the probability density function. So it can therefore take any value from a specified list of countable values or receive any numerical value inside an interval or the collection of intervals. So the discrete random variable means when the random variable takes a finite number of values, means just the values are the finite, then the such random variable is called discrete random variable. And for this random variable, the distribution, the probability distribution is called the discrete probability distribution, and binomial and the Poisson distributions are the examples of this probability distribution. So different forms of the probability distribution. Again, just I have explained here that one is the discrete probability distribution and second is the continuous probability distribution. Discrete probability distribution means the examples are binomial and Poisson, and the continuous probability distribution means the normal distribution. So normal distribution is an example of the continuous probability distribution. In a continuous probability distribution, the random variable takes infinite number of values. That means in a continuous form, and therefore this distribution is called continuous probability distribution. So today we are discussing on the binomial distribution. That means it is the example of the discrete probability distribution. So if the list of possible outcomes is discrete in nature, means what are the possibilities of outcomes for any random experiment. If it is discrete in nature, that means the possible outcomes are finite, and it is called the discrete probability distribution. And when like for example, when a dice is rolled, all the conceivable results, for instance, are discrete and results in a large number of outcomes. So when we just discuss for the rolling of a dice, then we can see just there are the limited outcomes are possible, finite number of outcomes are possible in a case of dice. So when the case of a single dice, then there are six possibilities. There are six possible outcomes, like 1, 2, 3, 4, 5, 6. But when we take two dice and we just roll together, then there will be 36 possibilities. 6 into 6, that means it is 36 possibilities are there. But as already we know that these 36 means it is a finite number of value. So therefore, this is an example of the again discrete probability distribution. So in a discrete probability distribution means in a binomial distribution, just what is the formula now we see. Therefore, the results of a binomial distributions are made up of an n repeated trials and can either happen or not. The binomial distribution formula is given by. So simply, suppose a random experiment is performed for n times, then the possibility for R success can be calculated by this formula. So this formula is given by P. P means the probability mass function. The probability mass function P x equal to R. X equal to R means here X is showing the random variable and R means the value of random variable about which just the probability mass function is calculated. So it is given by NCR. N means here the total number of times, how many times the experiment is just repeated. So NCR, Qn minus R, and PR. So P, small p is showing the probability for the event, whatever our event is there. So P means it is a probability of event, or we can say it is a probability of success. Q means the probability against the event, or we can say it is the probability of failure. R, again I have explained here. N means total possibility or total possible outcomes, and like R means about which the random experiment is calculated. So N is the total number of events. P is the success on a single trial probability. NCR. NCR is showing here the combination value of R possible outcomes from N. So that is NCR is the symbol of combination value from the N objects or N possibilities of events for the R number of events. It is given by in a mathematical formula N factorial divided by R factorial and N minus R factorial. Because we have told P is a probability for the success on a single trial probability. So it means Q. What is Q is showing here? The probability of failure. So it is a failure probability, and R is the total number of successful events. R, that is showing here total number of successful events. Now we take some examples to understand the concept of binomial distribution. Like see the first example, uh, counting the amount of materials used and unused during the product formation. So when a product is formed or in the part of the formation, uh, then just when we count the amount of materials which are used or which are not used, because it will be ultimately a finite value. So it shows the example of the just discrete or the binomial distribution. To collect both favorable and the unfavorable comments from the public on the same issue. So again, this is the example of the just binomial distribution to collect the both favorable and unfavorable comments from the public on the same issue. The ratio of men to the women employees in an organization. Next, counting the votes cast for a candidate in an election. So all these, just we can see here the value, the total value of the random variable means here the finite one. So therefore, this shows the binomial distribution. Binomial distribution is derived from the binomial uh, theory, binomial number, and from this the formula is derived. And here this formula is applicable for the two possibilities, one for the success and second for the failure. Now we take one example, when a coin is tossed 5 times. Determine the probability for the two heads and for at least four heads. So when a coin is tossed 5 times, so here just we have to see the question and what kind of this question is and from which distribution the question belongs. So if a coin is tossed 5 times, so n is equal to 5 because the experiment is repeated 5 times here. So it is n is equal to 5. Then question is determine the probability of for the two heads and for at least four heads. So it means, look at this one. The probability of head means what is our event? Suppose event is coming of head in the uh, tossing of a coin, then it means in a single for a single coin. So probability for the head is equal to 1 by 2, and it means P is equal to 1 by 2, and therefore probability for not getting head is q, and q is equal to 1 minus 1 by 2, that is 1 by 2. So these are the two possibilities here, head and tail, and we have just calculated their probabilities p and q. Now r is equal to 2 there. For the first question, for two heads, for the two heads means when a coin is tossed 5 times, so we are tossing the coin 5 times, so n is equal to 5, but we are discussing about the success for the two heads. It means r is equal to 2 there. The value of r is equal to 2, and therefore probability for the x equal to 2, that means 5c2, it is 5c2, and p square q 5 minus 2, is it? Px equal to 2 means 5c2, and just we have to put the values in this formula there. The formula, this one is just written previously. Look at this formula, ncr q n minus r and p to the power r. So it means p x equal to 2 is given by 5c2, and p raised to the power r means 2 there, and q raised to the power n minus r means 5 minus 2. So now just we have to solve with our calculator, with our calci. So P and Q are already calculated, and R is equal to 2 there, and N is equal to 2. So when we solve this one here, then we will get X value as 5 upon 16. So this is the question for the binomial distribution, and just we have found it here, the probability mass function, the probability for exactly two heads is coming there, 5 by 16. For at least four heads, second part of the question is for at least four heads. For at least four heads means a probability for x greater than or equal to 4 is required there. So because now what are the possibilities for the at least four heads? Because a coin is tossed 5 times. So it means there are two cases possible. There are two possible cases. One is for four number of heads, and second is for the five number of heads. So probability for x equal to 4 and probability for x equal to 5. So hence For probability for x equal to 4, how can we calculate? By the formula NCR. N is there 5 and R is there 4. NCR 5C4. Then Q raised to the power N minus R. N is 5 there and R is 4 there. So it is Q to the power 5 minus 4 and P to the power R means it is 4. And now we have to put the values of small p, small q and combination term. We have to solve it. So finally it becomes 5 by 32. 5 by 32, that is the probability for the 4 heads. Now probability for 5 heads in a similar way, it is 5C5 NCR. So 5C5 and Q raised to the power 5 minus 5 N minus R and P raised to the power 5. So when you solve it here, then we will get its value as 1 by 32. The probability for the 5 heads is equal to 1 by 32 and for the 4 heads it is 5 by 32. Therefore, the probability for x greater than or equal to 4. Probability for x greater than or equal to 4, it is given by 5 by 32 plus 1 by 32 and this equal to 6 by 32. That means it is 3 by 16. So this is the answer for the probability for at least 4 heads in this question. At least 4 heads. So this is the question from the binomial distribution. And we have to understand one of the important thing that in the binomial distribution, that is the binomial distribution is a part of the discrete probability distribution, and Poisson distribution is also the distribution or the discrete probability distribution. But there is difference between binomial and the Poisson distribution. In a Poisson distribution, the value of p, small p, should be very, very small. And in the case of binomial distribution, the value of small p means the probability for the single event, success of single event, then it is in the case of the binomial distribution, it is not very, very small. But in the case of Poisson distribution, it should be very, very small. In the case of binomial distribution, the value of n is not very large. It is not an average. It should be low. It should be a less value. It should be a low value like 10, 5, 15, 12, 20. But in the case of binomial Poisson distribution, the value of n means the number of trials must be sufficiently large. Sufficiently large means here it does not show a very large value and it does not show a very small value. So this is the case of the Poisson distribution, and we can see here the Poisson distribution means uh, it is the case of the it is the case of the discrete probability distribution. And in the today's lecture we have discussed about the binomial distribution, which is again a part of the discrete probability distribution. So this topic is again a very important part of mathematics, and here we have discussed about the concepts of probability distribution. So with this, I am concluding my today's lecture. Thank you.